inception as India Meteorological Department seismological unit and collaborative research work. So before going further, I would request Anup to please formally introduce today's speaker.
Thank you very much, sir. Very good afternoon to all of you. I'm Dr. Anup Mishra from IMD New Delhi, and I'm very delighted to get an opportunity to introduce our speaker for today's talk with the audience. We are honored to have Dr. O.P. Mishra with us. And Dr. O.P. Mishra obtained his MSc MTech degree from IIT Dhanbad in Applied Geophysics and DSc from Geodynamics Research Center, Japan in seismology. Presently, he is working with Ministry of Earth Sciences as advisor, scientist G, and director of National Center for Seismology. Dr. O.P. Mishra is a fellow of National Academy of Science, India, for his pioneering work involving applied geophysics, seismology, disaster risk management, having over 32 years of experience in different field of earth sciences and seismology and exploration geophysics. Dr. Mishra worked with IDRC Canada in a joint venture project with CMPDIL, Coal India during 1992 to 1995. And he served Geological Survey of India for about 20 years during 1995 to 2014. He worked with SARC Disaster Management Center, New Delhi as head and director. He also worked at GRC Japan as the foreign visiting guest professor. He is a life member of several professional bodies of international and national repute, such as AGU USA, SSJ Japan, Japan Geoscience Union, JPGU Japan, Asia Oceania Geosciences Society, AOGS Singapore, and International Union of Geodesy and Geophysics, IUZZ Germany, and Indian Meteorological Society India, IGU India. He's a recipient of several awards and honors, including visiting professorship by JSPS Japan in the year 2005, and the National Mineral Award in 2008 for Disaster Risk Management in Applied Geosciences by Government of India, and AS Arya Award 2014 by IIT Roorkee, Government of India, and Enni Talwani Gold Medal in 2015 by Indian Geophysical Union. Dr. Mishra has supervised and guided a total of 40 plus students and researchers for their higher studies during master and doctoral courses, including 10 scholars for their PhD degree from various universities in India. He has more than 200 research publications, including edited books, reports, special issues, roadmaps on various themes of seismology, geophysics, interdisciplinary earth sciences, DRR, in peer-reviewed journals of national and international repute. Kindly join me in welcoming Dr. Mishra.
Thank you, Anup. Now we request today's speaker, Dr. O.P. Mishra, to kindly deliver the lecture.
Thank you very much, Soni Sahab and Anup, all my colleagues, friends. It's really a great time to join our institution celebrations, that is 150th anniversary, that has a proven track record of the serving the nation since 150 years. And I have been given the opportunity to speak upon the most important aspects that was groomed by the India Meteorological Department since its inception. I'm very thankful to DG IMD and all colleagues that invitation was rendered to me, and I'm very honored to be here. The topic I have chosen as the growth of the Indian seismology science since its inception, and since inception as IMD Seismo unit, and now it is the National Center for Seismology as attached of the Ministry of Earth Sciences. So what was we are doing since then, since inception, and what collaborative research we have done and where we stand today. And all the credit I can put on record that all the credits of the development of the National Center for Seismology from the seismological unit from IMD goes to the IMD. and still they are supporting us. That how seismological research in the country was taken up in the beginning when there was a lot of the scarcity of the infrastructural. Even if whatever we have been proven through the available resources, it was really a miracle and Herculean task that Indian seismologists, Indian earth scientists, Indian atmospheric scientists played a role to bring this NCS to the service of the nation since 2041. So if you see the physiography of the South Asia, it was very beautiful physiography. And you can see that the India is the central part and it was surrounded by the very scenic mountains. And almost all South Asia, this scenic, it will go inside to its tectonics. Then you can see that this is equal to zone is actually associated with the factory of faults. You can see there are so many lineaments and the lines, broken lines, and there are the factory of faults. And these are actually the faults which are the causative factors for the generating the earthquakes. There are a lot of the lineaments which are not the fault, but these are the weak zones. And we can see that there is so many geological structures which are the defective to bring out to the brittle failure. So that means the none of the part of the South Asia, rather none of the part of the world is devoid of the earthquake. Similarly, in the Indian context, the India is surrounded by the almost all seismogenic prone tectonic zones, and India itself is a house of the lot of the earthquakes of the different magnitude and strength. If you go to see that, the Himalayan parts, there are a lot of the earthquakes happening from time to time. There are the lot of the earthquakes actually categorized on the basis of the magnitude. A magnitude is strength of the energy. So more the energy, there is the more the magnitude. So you can see that the greatest earthquake of 1897, it was there in the Shillong earthquake of magnitude 8.7. Thereafter, similar earthquakes occurred in the 1934, then occurred in 1950. Almost all earthquakes of magnitude 8 and 8.4, then 7.5. And then in that time, the India was the colony of the British colony. So 1897, when earthquake occurred, we have no any recording instruments or any permanent observatory to record the earthquakes. That's why this 1897 has brought the revolutionary change in the seismological science. And in that time, the seismology was in very nascent stage. So 1897, the 12th June 1897 earthquake, when the lot of the disasters happened to property and the people died, even the buried alive, the people in the Shillong and Assam, and then in that time it was decided that India should have one solitary permanent station, that is the stations in the Alipur, that is Kolkata, in 1898. So this caused a lot of damages. So this was actually I'm going to show you the damages of the different type. It is not only the earthquake shaking fully damaged, there is the half damage, there is due to liquefactions, there is also the tsunami-genic earthquake in the past happening. But the occurrences of the earthquake, its diagnostic properties and diagnostic regions were not known to us. That's why the India tried to understand that what was actually region behind the occurrences of the earthquake, how we can diagnose the actually diagnostic property that caused the earthquake, and under what conditions the seismogenic strength will lead to the earthquake, and under what seismogenic strength there will be no brittle failure. All these the challenging tasks are there. So as I mentioned that why it was so much disastrous, because earthquake is only the natural phenomena that has a tremendous amount of energy. You can see there is the x-axis where the equivalent to moment magnitude, that is the equivalent to strength, and y-axis has the energy released in joules and the equivalent to explosive. So you see the 9.5 magnitude is the world's highest, greatest earthquake recorded by the Chile earthquake. And then you can remember the Sumatra 9.3, it was not 9, it was 9.3. So it generates about 50 gigatons of explosive energy. You can imagine that even the 3 magnitude of energy, if there occurs, then there is 10 tons of explosive energy. So this is too much disastrous. But we are lucky that most of the energy is being absorbed and attenuated, dissipated, and scattered by the Mother Earth to the different strata. So some part of the energy come to the strata and causes the damages. So the challenge is that we have to take the understanding of the earthquake generating process, then we can take the remedial measures. But for this, we have to have a monitoring system. Without the monitoring, just like a body temperature measure, then you can see that how the body temperature is varying, when there is a fever, when there is no fever. when you are measuring the temperature and pressure of the any strata, then you can find out that what pressure is going on out built up. Similarly, the stress level of the earth is different. And if the seismogenic stress is exceeded by the shearing and bearing strength of the rock, then the rock breaks and then earthquake happens. So monitoring gives idea that we have to measure the stress level, at what level the stress is going to build up, what is the rate of the stress level, and at what level the stress is going to released or leakage can take place if the brittle failure taking place. So on going all these observations, we need observation system, seismographic system to address the crucial task. As I mentioned that all this going, we have to compute the source parameters in earthquakes, determine the physical properties of the earth interior, test the theory of the plate tectonics and map active faults, and then we have to see that what was actually the inference of the nature of the damaging ground shaking, how it was going on. So this gives you idea that if there is earthquake hazards taking place, then what could be the remedial measures. So these are actually the challenging tasks that can be done or that can be addressed by the monitoring system. So if you see I told you that 1897, the Shillong earthquakes, there was the 1897 first observatory of the Alipur, Kolkata happened. Then equal to in the 1905, Kangra earthquake happened. 1934, the Nepal earthquake happened. All the magnitude is 8 here. And 1940, and 6 observatory will be 1950 Assam. Then 6 observatory by 1940 we have to establish in India. And 1950 we have only 8 observatory. You can imagine that the country had the actually the 32,87,268 square kilometer area, having only the 8 observatories. In that time, it was very tedious to know the idea that how the stress is built up. So it was just like not a very comprehensive, but it was actually the earthquake prone zone, because Shillong, it was happening in the Shillong. So it was the Himalaya and the periphery of that. So Alipur Observatory and the other part of the geotectonic settings, they put on all the stations to find out what information we can able to get. And by 1960, 15 observatory by the worldwide seismographic stations we put up, and then we try to find out that what could be the actually the seismogenesis, means how the earthquake stress build up, and it can be recorded by the seismograph. So here the seismograph, I want to say you that seismograph is just like a cardiograph, just like the electrocardiograph, it measure the pulses of the heart. Similarly, the seismograph is measuring the pulses of the earth. So we can say that the earthquake is nothing but it is the heart attack of the earth. So we are, by this observation system, we able to find out that what was actually the seismographic feature, at what time the P arrival coming, and what is actually the response time between the first P arrival to the secondary wave. That means how much response time is there, because P wave is not the disastrous, S wave is the disastrous. So we can get the idea that we created by all this Jeffrey Boolean curve to find out the distance between what was the distance, epicentral distance and arrival time, and this all the research has been given. And similarly, almost all observatory system was slowly but steadily increased, and by 1917, 18 observatory established. And the most important thing is that in those days we have only the analog stations, means we have a very dynamic range, was very less. It was just like the 20 to 24 dB, that was dynamic range, and it was not sufficient to find out the informations in the digital form. So we have to read the seismogram, analog recorders are there, and we take a lot of times to find out that what was the onset of the P arrivals, what was its origin time, synchronized with the radio stations every time, and then you find out what was the Richter scale to find out the local magnitude. So it takes a lot of time to do the mathematical jugglery. But even if something is better than nothing, in that time the world was like that. So it was the India able to take the lead in the Indian subcontinent by putting up to 1917, 18 observatory stations, and IMD started to give the information whatever there, even the delayed information, but there was the authentic information was given by IMD to the world about the Indian subcontinent earthquakes. And and if you come to the 1990, there is a major change happens. By 1990, 18 observatory we have established, and mega earthquake happened in 1993. That is the Latur earthquake, we remember. and that was actually the a lot of the losses happens about so many people died, and it was realized that after the 1993 there was the 1990 1993, 1999, 1997, then 2001, almost all earthquakes consecutively happened in the plate interior. So Latur earthquake happened, 1997 Jabalpur earthquake happened, then you can go to 2001 Bhuj earthquake happened, and there is a massive destructions taking place. And then country took a lead that no, we have to have a denser network. Network is not only the analog, but it should be a digital, so that you can get the very precise and the highly resolvable informations on the seismogram, retrieved seismogram. So we try to manage all these the country, and by 2011 we have the 84 stations. 53 were the digital online through VSAT, that is the real-time stations. And I would like to mention that earlier we have the manual monitoring, means the data was recorded and then we can go and retrieve the data and then we do the processing. So manual monitoring takes a lot of time, but in 2011 we have to make a 53 digital online VSAT stations, telemetric, and the auto locations program. We have to earlier read on the saying the lens and then we read and do that, but we have the auto location program of the P and S wave you can do, and you know that the minimum 3 stations needed for locating the earthquake. So we try to cordon in such a way that the earthquake fall in those network whatever there. So we steadily you can see the 1897 to 2011 we have covered 80, we have able to manage 84 stations, permanent seismographic stations, and it was also the too-less. But if you grow, you want to see the further growth after the 2011 2004 your North Sumatra Andaman tsunami-genic earthquake, and we able to go back. We able to manage the entire stations is digital. By 2016, all stations, 150 stations will be established, and all were digital in the real-time mode. And now we have 2024, that is 166 observatory. So you can find out that up to 2011 we have only 84, but now 2024, that means within 13 years we crossed the double. So almost the double we make. So this was the fastest growth of the seismological parametric observatory. And that is one important point, is that this is not only the seismograph, this is the co-located with the acceleroph. And now the government of India is trying to do, and here in the 2011 afterward, there was the now the discussion in policy matter started to take place, that IMD is overloaded with so many activities of the atmosphere and all these things. Why not there should be a separate identity of the seismological division? And with support of the IMD and all think tank, there was the solitary national center, that is called National Center for Seismology, founded in 2014. And after the 2014, there is a drastic changes. There are the drastic upgradations in the instrumentations of seismic parametric observatory. There is also, you have to auto locations programs, high resolution techniques, algorithm used, and we have to also put up the online monitoring. And after that, we put the National Seismological Center in such a way that we have to take almost all work of the seismology as per the world standard, and we have to get all the round the clock monitoring, and we planning that we have 166 stations. Now we have to add another 100 stations, new stations at the different strategic tectonic belts. And we also tried to add that country as a consortium of the network, because many institutions in the country, they have their network in the isolation. So we wanted to make part of the national network, so it will be a consortium of the network. So we try to find out the almost on, and all stations are the broadband, because it's starting from the 120 to 50 hertz. Now there is a lot of sophistication, 360 to 50 hertz. So more broadband means you can able to get more number of the more precise, even a smaller number of the magnitude, because of the densification as well as precise equipment and manifestation taking place. And after this, we are round the clock monitoring, giving the information to the public and policy planners, stakeholders with authenticity, and also we explain that what is going to happening when the stress release is taking place. If there is any mega and moderate earthquake, then whether the situation and the fate of the coming 24 hours, any aftershock will happen or not. If aftershock series is taking place, then what could be the remedial measures and what will actually the chances of the occurrences of the any type of the bump up of the any magnitude earthquakes or not. We explain to the people, to the media, and try to give the information. But at the same time, National Center for Seismology realized that we cannot stop the earthquake and you cannot predict the earthquake. We can do the monitoring, but we can at least take the precautionary measures that we can mitigate the hazards as minimal as possible. So that's why you try to make the seismic hazard map, which is already made, that is based on very crude analysis of empirical law, that if you go from the epicenter far away from epicenter, then your shaking will be minimal. But it is not true always. You can see that even if the very well built structure was far away from the epicentral distance, far away from source, it was damaged. But dilapidated structure, very bad structure, found stainless steel in very near to the source. That means it was not empirical law. It was in situ material heterogeneity, means soil property of the foundation that gets amplified at the time of the earthquake shaking. And if the amplification take place, then the shaking frequency and building frequency match, and then resonance happen and building collapse. So that's why Ministry of Earth Sciences has taken the seismic microzonation study of the zonifying the zone 2, 3, 4, 5 in a such a way that find out where the actually the peak ground acceleration, how much peak ground acceleration per what grid point. So 500-meter grid point we have taken, and we took the zonification of each and every zone so that you can give the parameters for earthquake risk resilient structures. So next, and you can see the advance in seismological monitoring. I have already explained that almost all the 2015 Nepal earthquake, it was the credit of IMD, because in that time it was in transition to going from IMD to NCS, and whatever the Nepal earthquake parameters was estimated by the seismo unit of the IMD. In that time, the NCS was not in the formally taken up, though it was founded in August 2014. But whatever the location we made for the Nepal earthquake, it was the valid. But there was a hue and cry in the world that whatever the IMD already located this earthquake was wrong. Even USGS and other things they are given in the media. But we were sanguine that whatever location has been done for Nepal earthquake, it is correct. Still it is valid correct, and they changed their locations. So this gives us that our authenticity is the valid since its inception in the IMD. Of course, in late stages there were delay in recording time, delay in disseminating time. I will show you, but we have a very keen to give the authentic information to the public. Next. So you can see how equal to are progressing. So this was the analog to digital era. You can see that. So the actually 2001. So if the new millennium started, we switch over to the digital era. Go to next. So almost all monitoring taking place, and we have target to make it 300. And I think hopefully we will do that. Field monitoring we're doing, but it is not like that monitoring on center. Sometimes the major earthquake happens, mega earthquake happens. We also monitoring for the aftershocks. And like in the Palghar, you might have seen that there is a shaking. We set up a temporary network and monitor it to find out what is going on and give the information to public. So yes, so we got the advancement in the sensor, that is mechanical single SP sensors, and also we take the information in the recorders, as well as the 3-channel broadband high dynamic range, digital multi-channels, high dynamic equipments. So we took the communication systems, every aspects we updated since its inception. So whatever updation today we have, we are the best in the world, you can say. Though we have the sensor and permanent observatory in comparison to the other world is lesser, but the technology wise we are at the par of the world. So we have the good computational skills, we have the communication system fastest, recorder we have the high precision recorders, sensor is also world class sensors. We have also the almost all channels gain and all noise is the minimal, so we able to record the high resolution data. So next. Yeah, next. So this was divided 1992. Next. So you can see that the locations of permanent observatory is a very critical and tricky job. So we take the seismogenic tectonic zone, and then we decide that where we can put up the equipment, because equipment installation is very costly. Earthquake can hit anywhere at any point of time, but tectonic give us idea that this is seismogenic zone. So we put our stations in such a way that maximum number of the earthquake at maximum periphery we can able to record. So that is actually judicious decision. That's why we take the the hazard map as well as tectonics map to put our very costly equipment at the very strategic location where maximum information can be generated. At the time of the location, we also give the shaking map of the people. Sometimes you might be aware that when there was the West Nepal earthquake happened, then the Bahraich was shocked more. So in that time, you calculated the shake map and told that Bahraich has a lot of the peak ground acceleration because of the alluvial amplifications. Explained to the public, and they satisfied, and the people understand that. Otherwise, they thought that there is the earthquake in the Bahraich, so there is a lot of the panic. So we have to give the scientific explanation. Next. So real-time auto locations, P and S wave you do, and we take the, just I wanted to mention you that we can try to locate our earthquake in our SOP 0 degree to 40 degree north and 60 degree to 100 degree east. This is our SOP of almost all magnitude we reporting to our media, reporting to our bulletin. But if there is any disastrous or perceptible earthquake anywhere over the globe, we can also report that. Means our bulletin contains 0 to 40 degree north and 60 to 100 degree east, all data, almost all magnitude. But whenever there is the mega earthquakes, then you can give the information to that big earthquake also. Go to next. So the major, actually we received that, you may ask that, sir, how much time you can take to inform the public? We take now 3 to 5 minutes to give a complete information to the public with all explanation in the report. And this is one of the good achievement. You can see that it is one of the best. Earlier we can take 1 hour, 30 minutes, 8 and 10 minutes. So we means that more number of the observatories, more preciseness, more communication fast systems, more good algorithm, then we can able to give the information authentically in the minimum span of time. So that is your message, and that's why the NCS is trying to enhance or densify their network. Go to next. Go to next. Next. So this is actually the CRS called actually the central receiving stations, where our scientists working day and night, and whatever the informations we already processed and estimated, then that will be the actually communicated to the various communication means website, mobile app, SMS, fax, and also we have the Bhukamp app we have developed. Now we have the UDS system, Unified Dissemination System, so that we cannot, nobody can say that my one system is not working, so they cannot get information. We have also WhatsApp. So this is a very effective way of the communicating to the information to the public. So you can see how the day and night, and there was a lot of the precautions taken place that we cannot miss even the earthquake happened. You might be aware that in Wayanad, in the Wayanad, when there was the landslide happened and there was the hue and cry that there is the earthquake happens, it was the National Center for Seismology, Ministry of Earth Sciences. They checked and they found that this is not earthquake. This was due to the subtropical of the sound due to the all displacement of the rock masses due to the landslide. So there was nothing happened, and we checked all the things and given the information to public and press brief. So go to next. So here is the Bhukamp app, and that is most effective, and you can get the information to public then and there, just like in your weather forecast. And you can see that the actually almost all data since its inception recorded is now plotted here. And this plotted compilation was done by Rahukant. This was the professor of the IIT Madras, and all NCS data and every data has been given. And you can see that none of the part of the South Asia is devoid of the earthquake. And India, each and every part of the India, there is earthquake. Maybe the magnitude is the smaller or the moderate or maybe bigger, but you can see that it can hit anywhere at any point of time. This means that we have to put up the stations in each and every part of the country. And the magnitude is also varying from 8.7 to, you can see the 7.5, even 3.2, 3.2. So you can see the big magnitude. If the earthquake is a smaller magnitude but shallow depth, it will be the equally disastrous. If the earthquake will be the bigger magnitude of 7.5, but deeper is the, like suppose 30-40 kilometer of the 7.9 magnitude. But if your earthquake of the earthquake occurring of the magnitude 4.5, 4.9, 5, and its shallow depth is 11 to 12 kilometer, even 5 kilometer, 10 kilometer, then it was equally disastrous. So one magnitude change the energy of the 33 times. So suppose 4 magnitude, whatever energy x, the 6 magnitude will be the 33x. 7 magnitude is 33 into 33x. Okay, so it was the cumulative. Okay, so it was the too much energy generated, and that's why it was very disastrous. Okay, so but at the same time, suppose a smaller magnitude earthquake occurred, of the 3 magnitude occurred 10, then 2 magnitude will be the 10 times, that means 100. So more the magnitude is smaller, there was the lesser chances because stress started to leak. Okay, if there is a leakage of the stress in that zone. So sometimes series of the aftershocks occurred, very minor magnitude, the people gets a panic. In that case, we try to find out the stress level and give the information to the public. That it works actually. But sometimes questions there, and there is some a smaller earthquake happen, then it is alarming that there is no earthquake for last 10 years. Why there is a small earthquake happening in there? So we have to check it that there is any premonition or any foreshock or not. Although foreshocks are not detected till today, but we take the information on that. Next. So by taking this, we have to find out all this model that the plate, if you see the Indian plate is subducting beneath the Eurasian plate, and you can see the continental plate, and this was actually the locking part where the bending of the Indian plate taking place with the Sunda plate, and that was the broken in that time of the Sumatra subduction zone. Okay, so we gave the explanation that why the bigger earthquake happens. It was more competent and compact and locked zone broken, then there is a bigger earthquake happens. Okay, and then if it is occurring in the ocean, then it is tsunami-genic earthquake. So this is the type of the information we can go. Next. So all this earthquake information destination system, we able to now, I told you that give the informations, all this, and today we stand with almost all available communication means. Go to next. Next. So I told you in the beginning that we are going to augment the NSN with all the SMA network, and also the pilot study we are doing for the earthquake early warning system. Earthquake early warning system is different than the prediction of the earthquake and forecast of the earthquake. Earthquake early warning means it was the pseudonymous. It was the after the occurrence of the earthquake early warning. Of what? Early warning of the disaster phase. I told you that when earthquake happens, P wave generated. P is the primary wave. It is not disastrous. But when after P wave, S wave generated, surface wave generated, these are the disasters. So we find out that how long time take to generate the S wave. How long time it take from P to generate S wave. So that is called early warning. So it is early warning of the disaster P phase, disaster S wave and surface wave. So it was not like just say you are predicting the monsoon forecast and the cyclone forecast prior to the onset. But we cannot do that because when the earthquake occurred, P wave, then we get that it occurred. But now how it moves. So after the onset we are able to do. But here critical point is that the response time is very less because S minus P difference, if it is the epicentral distance is the smaller, then the S minus P is the minimal. So I tell you that S minus P is 3 seconds. That means the epicentral distance is 8 times of 3, means 84 kilometer, 24 kilometer, right? So if you are the 4 seconds, then 32 kilometer. So for very shorter distance of epicenter, then it was very much critical to give the early warning system. But it is good that we have the alert system, auto stoppage system, like the critical facilities like lift will be closed, power plant will close, electricity supply closed, gas lab closed, a particular threshold. What the world is doing and NCS is also doing in such a way that you can be more robust. I will show you after some times. So here SMA, I could show you SMA, a strong motion accelerogram. Means after the earthquake occurred, we wanted to see that how the wave is propagated. Means this wave is going to amplify somewhere. If amplify, then their building collapse may be taking place. So occurrences of the earthquake detected by the seismograph, and then SMA can take you the rupture propagation. How fast it is going, where it was amplifying, where it is going to seizure, where the rupture is terminated. But we are also planning to do co-located the GNS system, because prior to occurrence of earthquake, there may be the creeps, there may be the changes in the stress and deformations. That level we can able to see that, then you can manage that prior to brittle failure, what was actually the level of the creep and level of the actually the deformations in the rock masses. So we will be able to give out proper idea about the brittle failure. So if this is there, I told you that. So what is the seismic microgeneration? This is the all monitoring we are giving. People understand that where my house is. Actually, I am staying in the, suppose in the Himalayan range. So it is already early warning that you are staying in the hot spot of the earthquake. And one day a big earthquake can come, moderate earthquake come, you will be in danger. You have already early warning, forecast, siren. This is not like that, but people not understand. People just wait, let earthquake happens. So this is the thing that what to do. Nobody will ask you to leave the place of Himalaya. Nobody asks that Japan is the located in juxtaposition of the all three plates, right? Four plates, sorry. The Japan is just located at juxtaposition of four plates. You see the Okhotsk plate, the Philippine Sea plate, the Eurasian plate, and then the Philippine Sea plate. So Pacific, Philippine, Okhotsk, and your Eurasian plate. And Japan has the minimum magnitude cutoff is about 5.9. Japan is not leaving their entire locality. They are still growing. Why? They have to capture in such all the methodology in such a way that let earthquake happen, but whatever the disaster happening, they try to minimize the losses. How? They wanted to minimize the impact of the earthquake shaking on the structures. So that's why they try to do the earthquake risk resilient structure. Almost all countries, Taiwan is doing same thing, Japan doing same thing, China doing same thing, even the Parkfield and all America is doing same thing. India is now doing same thing. We are already doing the microgeneration study of the Delhi and many cities of the Himalaya. We have eight cities already going to be completed, 4 cities completed. So we have a plan to make the almost all strategic cities having population 5 lakhs and more is the micro zone, seismic micro zone. So this is the zonation map. You may ask that, sir, if there is zonation map, what is the use of the micro zonation map? The simple example. If the zonation map is correct, then your house, my house, and everybody's house in a particular zone, and if the same engineer can build up your structure, same material used, same design can be made, and almost all, every parameters are the same, a particular earthquake occurred of 6 magnitude at a particular depth, then everybody building should be damaged in a similar way. But it was not happening, right? That means the zone is not actually the way. There is some properties compromised here in this zonation map, and that property was the in situ material properties, which is actually causative for the amplification of the strata due to a seismic wave, and that wave matches to the frequency of the building and collapse happens. That's why you wanted to find out the different zone has a different stiffness coefficient of the soil materials. The different zone has a different soil property. The different zone has a different peak ground acceleration value at the different grid. That's why you're doing the seismic microgeneration by zonifying this in a such a way that we can give a proper design parameters to the builders or to the BIS. They can make a sound building design code. So next. So you can see there is a lot of the parameters, actually the geological, geophysical, seismological, geotechnical, and all is combined, and then you make it, make all these parameters and then simulate it. Go to next. And just like you can see the amplification parameter for the and your peak ground acceleration. So you, it's okay, all right. So you can see that the red zone is more hazardous, means here. So the more frequency and here the amplification. It was the reverse relation. More the frequency, mine means harder rock. So amplification will be less, right? And if it was the less frequency, it was the weaker. Okay, less frequency, it was the weaker. That means its amplification is high. So we wanted to find out in such a way that where we are going to find out a foundation. Go to next. So you can see this seismic microgeneration of undergoing cities of the Chennai and the your hazard map of this. You can find out the hazard zone. Go to next. You see the other cities of the hazard map of the Bhubaneswar and the map of the Mangalore. We try to do all microgeneration studies of the coastal belts also. Go to next. And by that way, the NCS is trying to complete the 30 cities of microgenetions. Almost all 12, you can see all completed, whatever given, and remaining cities on the process of the completing next financial cycles. So by that way, we can able to give the design parameters, the inputs that BIS can introduce in the new building design code. So we will be the earthquake risk resilient country by 2047, right? So go to next. So here is I told you that we are getting the information from grid wise 500 meter by 500 meters, 1:10,000 to 100, 1:5,000, right? But now it is going to be not a microgeneration. The day is coming that we can going to for nanogeneration, can go to your picogeneration or femtogeneration, means your grid spacing is too narrow. So more the grid spacing narrow, you have to detail information. Means if the earthquake happens, then it is, you can see that in the Delhi, which part of Delhi is more damage, or which part of South Delhi is more damage, or which part of the Lodi Garden is more damage, which part of Lodi Garden which part of the Lodi garden is going to more damage, which part of the NCS building is going to more damage. This is called actually the picogenesis, right? You are pointing out means which in this room, which corner of this building is going to more damage. So that was the more precise, more distinct if our grid is the lesser, means 1:50 meters. Okay. So we can going to do all this microgeneration. So this was the actually. So we are now in the first stage, that is the third grade of the microgeneration we are going to complete. After that, we can do for vital installations like your power plant, like the defense, like your space buildings, okay, administrative buildings, we can do for that. Go to next. So by that way, in microgeneration, we can have a safety of the schools, safety of the hospitals, safety of the prisons. Prison safety is also jaruri hai. Because Haiti earthquake, we remember that when Haiti earthquake happened, in what happens? Almost all prisoners come out and they started to loot the rasad kam jitna jo rehabilitation materials they wanted to take out and created the problem. So prisoners must not be come out during the disaster. They should be actually in that zone. But the government and the world try to understand that hospitals, schools, and prisons are equally important. All critical buildings, all the railway routes, all the the airports, all the sea routes, everything is there. So flora and fauna will be protected. So it is a sustainable plan for risk resilient setup. Go to next. So you may happen that since we are born from the IMD, so we always try to work with IMD. You see, so our researchers have tried to do the earth and space science, that if there is a cyclone and our network there in the coastal belt, can we get any type of the signals on the Amphan cyclone that the tracking can be done? And it was a very classical paper published in AGU by our NCS scientist, and we corroborate that the seismographic network can be worked for the multi-purposes. Okay. We also try to work in a very classical study in monsoon-induced earthquake in Talala, in the Gujarat, and now in the almost all area of the plate interiors. That if there is a monsoon-induced earthquake, then the monsoon water precipitation try to percolate to the shallow level to the mid crustal levels through the active, hidden, mysterious the faults which are connected to the subsurface or cracks or the fractured rocks of the volume, and then they try to hasten the failure. So hasten because of the water lubrication, it was the slip taking place, and then the earthquake happened, and it was very corroborated with the water level of the water. This paper was there, so I have not shown the result. You can note down and you can read the paper, and you can also work on this. So you can monsoon-induced earthquake is one of the classical example, Amphan cyclones, and we try to work on this way, that how the seismological data can support the inferences of the atmospheric results. Okay, so this is there. Go to next. So you can see the Coda wave, we have to already research articles done, and all attenuation structure has been done. And we also find out that Indian Ocean research we are also doing, that if Indian Ocean, then what information we can give to the ocean research. Okay, because it is only seismology having deep probing potential. They can peep inside the suboceanic, sub-ocean, means beneath the ocean floor, and this is only seismology to give the information. And we have done the attenuation structure for the Indian Oceans. What now the blue economy and your what is called ocean deep ocean mission is taking place. I think our seismological research is first pioneering to understand that what is lying beneath that before puncturing of the any place. Go to next. So earthquake early warning, we're trying to do that because this is the earthquake early warning we're given you the epicenter and all. But here I can say blind zone. Blind zone means a zone who takes a time for calculation. Suppose earthquake recorded, then calculate what is the magnitude, what is the location, what is that. So it takes a lot of time. So quickly do, and then you can predict that this is the S wave going to. So this was the time consuming. So world is doing on that. And go to next. But we try to be a different type of things. We don't want to doing that. We try to do another type of the earthquake warning, that let the earthquake recorded, and from record we can give the early warning. And it was in the nascent stage. So it come out. That's why it was called a POPA, means post P arrival early warning. So we are now in the place of development. We've taken a case study, pilot study in the Himachal Pradesh. Go to next. Next. So we have taken the proposed in the earthquake early warning in Northwest Himalaya, in the Himachal Pradesh, taking a long dense network, And from there, we put the strong seismographs, and then we try to find out the mathematical all authenticated algorithm, and then we can give the information without losing the time in more calculations, because world is only worry for the damage. So we don't calculate parameter. Nobody is worried for a parameter. Only they have to assess that this earthquake is going to be a disastrous, and that disaster information we are going to give. Okay, next. So the significant of progression in seismological algorithm for relocating earthquake. So you can see that the mud volcano and lava volcano we also explained by this recording of the earthquakes. Go to next. So you can see the all Andaman Nicobar. Here the Soni Sahab, almost all stations are in the state, in the land area, in the state line, although the earthquake occurred in the either side of that. So you can see that the location of the earthquake is not correct here, because in order to locate the depth location, the earthquake must fall in the network. Means if you wanted to cordon a culprit, then police should have to cordon the house. Then he can be shoot out. Otherwise, you are sitting in the Bombay and you are trying to shoot your culprit in the Calcutta, it is not possible. So if we all are the policemen, we all the seismograph, and if the earthquake occurred here, we can able to nab clearly. That's why this is not possible. So this is actually the technique I developed in my DSc in Japan, that all suboceanic earthquake, let it occur in the subocean, let it be recorded in the land stations outside of network. Then we develop a technique, I'll show you. Go to next. You see, that is called SP minus P depth technique. So we saved the money of the OBS, ocean bottom seismometer. It is a very costly affair. So if you set up ocean bottom seismometer, may not be the earthquake occurred there. And on that technique, the location of the earthquake is as accurate as OBS. So go to next. And by doing that, we have to find out the almost all structures. And you can go to next and see the lava volcano, mud volcano in the Rangat. We give the explanation. Go to next. And we explain that why it is happening, because of the compressive force. Go to next. And then we also predicted that if the cycle of the aftershock taking place, then the lava will be erupted. In 2005, it was erupted. And then it was, so this says the actually authenticity of the seismology. If you do the good modeling, you are able to do that. And how you do the modeling, I'll show you the tomography. Go to next. So this is the tomography. You go to next. You see how many type of the, you see the how many crease of range. So the you can find out the square is your stations, okay, and there outside is the earthquake. So many crisscross take place, just like the pumping of the bullet, and you sanguine that I have already killed him, right? So this almost all zone is the sampled properly to do the tomographic imaging, and we did the tomographic imaging. After that, go to next, and you see the tomography. Go to cross section. You see the cross section. So Byron volcano, you see the red zone, it is the low velocity zone. It was the lava volcano. But in the Baratang, you can see there is the slurry material, only the red, but there is the blue zone. It is the high compact force, which is compressive force that is causing the eruption of ejection of the slurry materials, right? And we image the magma chamber depth is here, the 20 kilometer, first time in the history of the Byron volcanic area on doing the tomography technique. And this is actually the work recognized by the national government of India and give the National Mineral Award for that. Go to next. So we have the way forward. What we have to quick dissemination of the earthquake and densification of the network with the existing as well as many stations. We have to add this seismic microgeneration of the all cities going on, and the more cities can be added. And then earthquake early warning is the pilot project in Himachal Pradesh is taken up, and then multidisciplinary research, monsoon-induced earthquake, cyclone tracking, seismograph, and ocean-based research should be continued. It is our mission under the mission of our NCS. Next. Thank you. Zyada time mein liya na?
Nice. Thank you, sir, for very nice and
You understand
very
all?
informative. Yes. So it was explained in very simple language. So even the people who are not very familiar with earthquake science can understand things. So we are now open for few questions, and let me start from asking few questions here. My questions will be very innocent, or you can say
please.
the layman type of questions here. That actually this Indian plate is moving eastward here. So the first question is why actually these plates are moving eastward. And second, that we hear a lot of news or like that here, that the movement of Indian plate will also tear apart the Tibetan region here, Tibetan plateau. So why actually it is moving eastward, and whether it is that any influence on Tibetan plateau with this movement?
Very good. Actually, if you see when the India, when the rather Pangaea, that was the rock massage when broken in 175 to 180 million years ago, and then Laurasia is above, that was in the northern part, and Gondwana is in the southern part, and India was at with the Antarctica. Okay. Now, because of the dynamic force, this is the mantle is the actually dynamo. Mantle has the viscous materials. So they wanted to have the passage of the movement of the drift along the drift path, So whenever the force is taking place, the different plate disorientation taking place. So if you see in the Indian structures, Indian means all plate dispositions, you can see that most are the locked part. Okay, only the Indian part is coming from Antarctica. They are getting a free passage, and that was only the northeast directions. If you see all are the locked part, and there was all the dynamo, and the velocity was very high in that time, 50 centimeters per year. So you can even if it was coming to a passage, and there were the propelling path of there, then it tried to get the amplification factor called a reunion hotspot. So reunion hotspot, when it is translated, they get another energy, that is heat thermal energy. And reunion hotspot's directions was towards the northeast. So the lava flow means the viscous material, the flow was also the northeast directions. So in case the flow directions was there, so anything can move. If suppose the water is going, water can only go in the slope directions, or water can go only there is the path. Water can go. So the passage of the path of the mantle dynamics was towards the northeast, because they act, but now it was slowing up 5 centimeter per hour, because now the people telling that mantle is cooler now, it is going to cooler, that's why it's there. But different has a different rate. But India is now in that case is there. So the movement directions is the northeast because of the propelling directions of the viscous materials of the mantle dynamism. Okay, and there is loss of the Coriolis force also in this case. You can see that then if you calculate that, it is also exactly matching to that directions. So obliquely, now obliquely is also the question. Why it is obliquely? Why it is in the north direction? Oblique is oblique changes every time. Could it be the northeast to the coming to the further tilt? So all these things are there. Still, you have to know other techniques than your seismological or geomagnetic field. So geomagnetic field also says that measurement of geomagnetic field also says that geomagnetism is also a guiding force, that where the plate moves means the axis of the rotations and axis of translation must also balance. So by that way, Earth itself is a very it is the natural forces. So to try to have a geomagnetic force balances also. So that's why there was the Indian plate moving on that way. And what do you next, Tibet?
Have any effect on Tibet? We will say that it will tear apart the.
Actually, when before the Himalaya, Tibet was the highest mountain. Okay, so at the time of the isostasy when taking place, then the Himalaya is rising and Tibet is getting sagging. Okay, now the question arises that if there is the root and anti-root effects is there. I told you that if mantle is dynamic, that means there is upwarp of mantle. Upwarp means convex. If mantle upwarp, that's why the 2 millimeter per year Himalaya height is rising. Okay, so it was all the things, but I think it was all associated processes. We can say that there is impact of that, but we cannot say that because of that other impact will be also. So sometimes some impact is looking after, but some other impact is also nullifying that, may not be occurring on the Tibet. So it was very so much concrete evidence for that. But Himalaya and Indian plate and Tibetan plate are very interrelated to each other. And it was as a whole we can understand that Tibetan plateau its origin and other our Indian plateau's origin is more or less of of the same origin. Sometimes chemical differentiation, sometimes physical processes, sometimes tectonic evidence. But Tibet has a lot of the, I think, in-depth regional aspects. So it was there, and more or less Tibet is now locked part. It is the most important thing. Tibet is a locked part. So it was subjected to the compressive stress. So tearing can be possible. Suppose I go to convergence force from this direction, and if you are so strong, I can split you. Okay. So it was the convergence in that direction. So tearing could be possible. That's why there are a lot of the neotectonic faults. There is a lot of the active faults. There is a lot of the hidden faults which have not still been mapped. They are quite possible in tectonic regions. But nature is very clever. One creates, the other try to nullify that effect. Okay. Otherwise, there is no survival. That's why I told you that Earth is subjected to so many bigger earthquakes of magnitude 9. And it has, I forgot to tell you that it has a lot of the energy generated that has capability to tilt the axis of rotation. And if the axis of rotation tilted, then there is the abnormality change in secular motion. If secular motion abnormality taking place, then there is a change in the ऋतु परिवर्तन. हम लोग पढ़े geography किताब में. So if carbon emission is zero, you cannot tell that there will be no climate change, because every geological age there is the climate change. Every geological age, in that time there is no population, there is no carbon emission. Itself, ocean has carbon and oxygen and all these things. Ocean itself is doing that. So this was very that big earthquake can contribute to climate change. A smaller earthquake can be a proxy of climate change, because a smaller earthquake is occurring when the melting of the ice taking place, the load of the ice is lessening. Then there is what? Then there is the micro earthquake taking place. So more the polar region, more the smaller earthquake can say that there is global warming taking place, right? So we have written in the science nature in the current science paper many times. We have also elaborated that that could be the region for that. So nature itself is very compromising and very supporting to us.
Sir, how many these stations are required to accurately estimate the magnitude of earthquake?
Actually, it well said that today at present, all over country 3 magnitude earthquake you can able to properly locate. But if you wanted to know more precise, lesser than 1, because lesser than 1 give you example that now the neotectonic activity taking place. So if the length and breadth, if when I remember 32.16 and 33.15 and all, length and breadth, we need minimum 5,000 permanent stations in comparison to the global world. Japan has 7,000 in such a small country. But of course, the seismogenic zone is entire in comparison to our plate interior is there, where frequency is less. So our target is that we can make at least 3,000. But 3,000 done, warp footing we have done it.
Is there any relation also between P and S wave? Means P will be of this magnitude, then S will be of that magnitude.
No, actually, magnitude can be determined by the body wave, that is P and S wave, as you rightly said. But this is my body wave, it is for the deeper earthquake, body wave magnitude. But P is always for one particular earthquake, and S wave is also dictating that. Shear wave means it was the what is called your destructive wave. It was depend on the if the magnitude is more, then it will be the higher amplification. And if it is the magnitude more, P will be also higher amplification. So he rightly says more the magnitude, the P and S will be more precise. Okay, more amplified. It is more visible. दूर से ही दिखेगा ये P है ये S है. But if it was the small, shallower, then it was the passing through so many strata, so it is not be there. But P and S is the distinct feature of a particular earthquake. So more the magnitude, clear the reading of P and S on seismogram.
Is there any satellite technique for monitoring and verification?
Of course, I think it is the we are thinking for that. That if there is the electron content monitoring we are doing, but it was not exactly the P and S wave. Electron content means if suppose there is the earthquake, it build up. Then because of the commotion of stress, some the gaseous material try to come up and adding to the exosphere. So electron content by GPSTC, total electron content, it can be measuring, and the world is doing that. We can say that, oh, there is some zone is here from where the electron emission taking place. So we have to corroborate in a holistic way in order to earthquake forecast system. This is one of the aspects that we are thinking, that how the satellite can do that. Satellite GNSS monitoring can be done. So how to GNSS monitoring or ground GNSS monitoring can be clubbed with the seismograph and accelegraph monitoring.
For a particular state, if any low magnitude earthquakes happen in a month like 2, 3, it is reduce the chance for a major earthquake?
Generally, you have to go for the tectonics and can see that whether it is occurring for the first time or occurring and past history is there or not. And it is the, of course, this is the occurring on a known fault or there is some new tectonic activity taking place. So both aspects is there, but generally says that if in that zone, if the number of the earthquakes is occurring, too many number of occurring of the lower magnitude, there is no building of the stress level. So there is just like a bucket you are filling up, but bucket is leakage of the water, right? So a small earthquake is the occurring, so stress is releasing. So that is not going to impede big earthquake of that zone of more than that which already happened. You understand? But thing is that if the known fault is there and some other part of the fault is breaking and other fault is intact, other part of the fault intact, could be that that is going to accumulate there and can lead to the big earthquake. So you have to see the tectonic aspects also.
Sir, what makes earthquake prediction a difficult task? Whether it is lack of network, lack of sensing technology, or dynamic nature or uncertainty in that earthquake?
Very good question, actually. 100 years ago, doctors not able to tell you that heart can be transplanted, brain can be transplanted. Why? They were not understanding the mechanism of the heart functioning and brain functioning. But now, similar processes here. We don't understand that how the earthquake built up. We know that shearing and bearing strength of the rock exceeded the by the stress, then rock breaks. But there is many things. We have tried that taking the granite and taking a basalt, and we know that stress is built up. We know that granite is maximum stress is this. We measure the stress in granite. It was not broken in situ. So the main problem is that we're not able to predict the earthquake, forecast the earthquake, because the physics involved in it or with present state of knowledge is not clearly adequately explained today. And for this, it is a multidisciplinary science. We need to know that what was actually the going on. Research is going on for that. But we are not in skeptical that it will not done. Because I told you that 100 years doctor cannot do, but now they are doing. So similarly, we understand the mechanism, many things, but most of things are still not known. So once the complete physics of the earthquake will be known, generating processes and mechanism will be known, we will be able to predict that. Okay. So it needs your upgradation of the instrumentations, algorithms, interpretations, many things are there. So it is good questions, and that's why we should not stop that we cannot predict the earthquake. That's why we are trying to make earthquake risk resilient structure. Let it be happen, we will be safer, right?
AIML will predict, sir.
AIML actually AIML is not the god, you know. AIML क्या करता है कि जैसे मुझे किसी स्ट्राटा से मुझे 2 ग्राम हीरा मिला, हम उतना ही नेकेड आई से और मैं अपने इंटरप्रिटेशन 2 ग्राम देखा. AIML क्या करेगा, उस 2 ग्राम को उसके भीतर में और 3 ग्राम है वो निकालेगा. So AIML can harness the extraction of the information. Suppose in seismogram is the cumulative. Seismogram coming from the all strata. We are getting information of P and S wave, but it is waveform. Some informations we are getting is not adequate to understand the processes, but AIML can help us that this is the information. Okay, but that there may be because Earth is very complicated, very intricate. So it can help us to understand or help us to enrich our knowledge. But you cannot say that it can help in prediction. Of course, the algorithm is now more algorithm is okay. But AIML training data and all data, how you train, how you are seeing. AIML भी आदमी बनाया ना, अपने से नहीं बन गया. ChatGPT अपने से नहीं बना, आप ही बनाया, आप ही के brain बनाया. But what information we are giving and what could be there? So maybe sometimes artifacts also come in AIML. So who will control the artifacts? The tomography में हमने इतना क्रिस क्रॉस दिखाया, व्हाई मे आस्क व्हाई, बिकॉज वी रिमूव द आर्टिफैक्ट्स, वी वांट टू गेट फैक्ट्स, मींस मोर द क्रिस क्रॉस मोर द फैक्ट, मींस आप भी बोला वो भी बोला, भी सब ठीक है, डेमोक्रेसी राइट में से होता है, लेकिन साइंटिफिक में डेमोक्रेसी अलग होता है। आपका एक्सप्लेनेशन, इनका एक्सप्लेनेशन, यस इट इज लाइबल टू ठीक है। यदि आपको कोई ग्रेविटी से डेंसिटी निकालिए या पलरा से डेंसिटी निकालिए या और किसी से डेंसिटी निकालिए, डेंसिटी होना चाहिए उतना ही। ऐसा तो नहीं है कि हमने डेंसिटी निकाला, आपका अलग हुआ, उसका अलग हुआ, उसका अलग हुआ। साइंस कहता है कि जो भी टेक्निक लगाइए, इंफॉर्मेशन मस्ट बी द सेम। तो इसलिए है कि टूल कैन बी यूज्ड फॉर enrichment of our ideas, knowledge. It can help, but we have to need a tool. Okay, it's good. यही तो पता नहीं है, यही तो पता है कि हम कहाँ खड़े हैं अभी। लेकिन पहले देखो, आप बताओ, देखो प्रिडिक्शन के 4 स्टेज होते हैं, मेरे पेपर में भी लिखा है। प्रिडिक्शन के 4 स्टेज हैं, जिसमें हम 3 स्टेज पार कर चुके हैं, एक ही स्टेज बाकी है अर्थक्वेक का। एक है प्रिडिक्शन का एंटीसिपेशन, आप एंटीसिपेट करो कहाँ अर्थक्वेक होगा, आंख बंद करके बोलो हिमालय में होगा। तो हिमालय को डिमार्केट किसने किया? जियो साइंटिस्ट ने किया। प्लेट बाउंड्री किसने बनाया? जियो साइंटिस्ट ने कहा। तो आप आंख बंद करके बोलोगे सर हिमालय में होगा, सर पैसिफिक में होगा। आप एंटीसिपेट कर रही हो बेस्ड ऑन योर साइंस, ये एंटीसिपेशन है। दूसरा क्या करती हो आप उसको एक्सपेक्ट करती हो कि सर बड़ा अर्थक्वेक जो है ना शिलोंग में 1897 में आया है, अभी तो कोई अर्थक्वेक नहीं हुआ, ये जरूर ड्यू है। अर्थक्वेक कहीं ना कहीं एनर्जी रिलीज थ्योरी का कहता है कि ये एनर्जी रिलीज होगा, कहीं जाकर एक्यूमुलेट होगा, तो जरूर सर कहीं ना कहीं पर ये एक्यूमुलेट होकर बड़ा अर्थक्वेक होने का चांसेज है। तो आप क्या कर रही हो, उसको आप एक्सपेक्ट कर रही हो। इसका भी रिकरेंस इंटरवल से आप बोलती हो एक्सपेक्टेशन की अभी होने वाला है, 50 वर्ष हो गया, सारा वर्ल्ड करता है। नानकाई के ऊपर रिसर्च चला जापान का, 1946 में नानकाई ट्रफ वाज ब्रोकन। तो इसका ये है। तीसरा स्टेज है कि आप उसको जस्टिफिकेशन कर रही हो, आप कि हाँ साइंटिफिक बेस्ड ऑन के जस्टिफाई कर रही हो, ये सब हो गया आपका। लेकिन ऑथेंटिकेशन विथ रेफरेंस टू टाइम, साइज, विथ रेफरेंस टू टाइम, साइज एंड प्लेस, ये नहीं हो पाया। जब ये ऑथेंटिकेट कर दोगी आप, तो आपको प्रोडक्शन हो जाएगा। तो हम अभी क्या कर रहे हैं, हम अभी प्रिडिक्ट कर रहे हैं विदाउट रेफरेंस टू टाइम, प्लेस एंड साइज। कितना अर्थक्वेक होगा हिमालय में? तुम बोल सकते 3 या 3.5 हो सकता है सर, ठीक है, ये भी ठीक है, लेकिन कहां, किस लैटिट्यूड पर, कब, कितने डेप्थ पर, ये नहीं कर सकते। ये जिस दिन हो जाएगा उस दिन हो जाएगा। जैसे कि आप साइक्लोन बोलते हो कि यहां से चला, यहां वेव जाकर टकराएगा, यहां जा गिरेगा, गिरता है कि नहीं? तो प्रोडक्शन एंड फोरकास्ट वी नीड द ऑथेंटिसिटी डिटर्मिनिस्टिक प्रोसेस। और ये जियोफिजिक्स से हर चीज अर्थ प्लैनेटरी साइंस में ये नॉन यूनिक सोल्यूशन है। हम लोग टोमोग्राफी में इसको बोलते हैं डायफोंटाइन इक्वेशन। मींस वी हैव, सपोज वी हैव 10 स्टेशंस एंड वी हैव 100 अर्थक्वेक रिकॉर्डेड। कितना मैट्रिक्स होगा? 100 into 10,000। उसका सोल्यूशन करेंगे आप, सो मेनी न्यूमरस सॉल्यूशंस आएगा। मतलब हमें तो अर्थक्वेक का मैग्नीट्यूड जानना है, अर्थक्वेक का डेप्थ जानना है, अर्थक्वेक का लैटिट्यूड लॉन्गिट्यूड जानना है, टाइम जानना, 4 ही जानना है। लेकिन मेरे पास इक्वेशन कितने हैं? 1000। सो आई हैव टू फाइंड आउट द यूनिक सॉल्यूशन आउट ऑफ द 1000 इक्वेशंस, and that takes a lot of the corroboration, prior information from geology, from tectonics, from the archival data, from the past history, from the already कुछ available है कि नहीं। आप जानते हो कि पेलियो अर्थक्वेक हो रहा है, कहीं अर्थक्वेक नहीं हुआ तो नहीं, पहले तो यहाँ अर्थक्वेक हुआ था, पहले तो यहाँ पर वोल्केनो था, पहले तो यहाँ पर ये था। तो ये सब चीज है, इसलिए अभी लास्ट स्टेज के लिए हम लोग काम कर रहे हैं। Yeah, tomography में we plotted the tomography. I see the cross sections and then तुम जाओ थोड़ा 1 मिनट। हाँ पीपीटी में जाओ, लास्ट वाला में जाओ। एकदम लास्ट में जाओ, वोल्केनो में। हाँ हाँ हाँ, उसी में। हाँ 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 हाँ, उसके ऊपर, उसके ऊपर, और उसके नीचे, उसके नीचे, नीचे नीचे। हाँ बस ये उसके नीचे। हाँ देखो, ये प्लॉट क्या है ना, डेप्थ वर्सेस लॉन्गिट्यूड लैटिट्यूड है। सो वी इन्वर्ट द एवरी ग्रिड लैटिट्यूड लॉन्गिट्यूड, every grid latitude, longitude and depth we inverted and get the value of the velocity. Okay, and then we plotted the velocity and then found that it is the low velocity. So where is the low velocity? You can see that was the low velocity up to 20. You can see up to 20 kilometer extended. देख रहे हो ना 90 बैरन के नीचे तक देखो. So this was the actually magma chamber depth. Okay. After that, this is the what is called? It was the basement. Okay, Indian plate basement. Yes. हाँ सर, और किसका? सर का है? हाँ. हाँ सर, प्लीज.
मिश्रा जी,
सर प्रणाम.
प्रणाम. कैसे हैं? बहुत बढ़िया लेक्चर है
सर. आपको प्रणाम सर.
एक क्लैरिफिकेशन. अभी जो
Sir.
है रेनफॉल वाज द ट्रिगर फॉर लैंडस्लाइड्स. दैट इज द मेन अंडरस्टैंडिंग सो फार. Now there is some guidance is coming that subsurface tectonic movements and or low intensity earthquakes are destabilizing the slopes over and above the rainfall. How much guidance from the tectonic movements and your seismological information, potential destabilization slopes and future vulnerable for landslides can be obtained?
Oh, sir. Sir, the main feature of the landslide, the rock cohesive force looseness means actually the reduction of the cohesive force of the any rock masses is because of tectonic forces. Now, if the tectonic forces, there is a crack and fractures, and if then rain precipitation happen, then due to the percolations and gushing of the rainwater, that was actually widened, and then cohesive force is further get reduced and further diminished. So the probability is increasing. So the main reason is the tectonic subjection of the stress and then creation of fractures and cracks. Then it was the filling of the rainwater and percolations and that causing the processes. Now, sir, in subsidence cases, there is a lot of the evidence also that if any impact will happen, either in case of the subsidence or any type of the thumping or any type of the anthropogenic activity, when the rock exposed further, not only to rainfall, either to the heat or the weathering effects, then it enhances the landslides too. So these are, sir, I think the valid reasons for actually bringing out the landslides. And it was a very, not only one region, it was the actually more than 1 and 2. So it could be the, just like in the, sir, Kedarnath the tragedy, you remember that the moraine was the broken because of the microseismicity.
Yes.
And then there was the partial differential temperature happens, and then the melting of the Chorabari lake happens, and then there was the landslides and all things happens. So one instigate other. So you were rightly said, sir, that there is the involvement of the all three effects.
But is it possible to isolate the potential destabilization factor from the seismological information and tectonic movements?
Yeah, that can be done, sir. That can be done. Easily that can be done. Because if there is the GNSS monitoring, we can able to see that prior to occurrence of landslide, what will be the rate of the creep. So how actually the cohesive force is getting down, stiffness coefficient is reducing. And after that, if there is the rainy seasons also, further it can give you the idea that what type of the reinforcement due to the hydrostatic pressure taking place. So water monitoring saturation means crack and saturation rate monitoring can be done. So it can be isolated, sir, by doing that.
But can NCS spend some resources and time to get this kind of guidance for IMD?
We can do that, sir. We can do because we have the crack density saturation rate monitoring and GNSS stations. We can also we have the GPS team, but the area we have to take it some pilot study, and then you can able to isolate and do that.
Maybe you can pick it up any of the hill states where your network is more dense, and
Sir.
then maybe you should consider helping IMD in getting these vulnerability of landslides.
It will be great, sir. It will be great, sir.
Thank you so much. Thank you so much.
Thank you, sir. Thank you.
Sir, currently I started receiving call from my so from village people are calling ki earthquake is coming.
So in midnight, like in UP cities and more, even Delhi, people came out from their homes कि earthquake आ रहा है, बाहर आ जाओ. तो NCS क्या उसके लिए क्या preparedness है या कैसे उसको tackle करना है? जिससे
देखो,
हम उस condition में
whenever there is the earthquake, NCS is the first to listen and first to awake the people.
Yes.
And we give the informations to all media, all over places, whatever possible. Now somebody trying to create a propaganda, we also justify that this is not a propaganda at all. Many places, many times NCS has given the clarification, it happens. Sometimes the one or two irresponsible comments has been given by the one guy, he has already predicted earthquake occurring and this, that. Somebody has hobby to do that. But whenever it is impossible to predict the earthquake when it is coming. If we can predict the earthquake, then world can predict. I think no sensible organization in the world can predict the earthquake. Can you tell me they have predicted the earthquake?
सर मेरा एक्चुअली क्वेश्चन ये है कि मतलब जैसे वो एक हॉक्स हुआ फिर पूरे गांव में लोग
हॉक्स होता, यस, हम
रात
वही
में
बोले.
वो एकदम परेशान
नहीं,
मतलब
हॉक्स
सब
होने के
बाहर
बाद
निकल
नहीं,
नहीं है
हॉक्स
तो
होने
उस
के
इमीडिएट
नहीं
कंडीशन में क्या मतलब
हॉक्स होने के बाद एनसीएस को जब न्यूज में आता है तो एनसीएस उसकी जस्टिफिकेशन करती है. एनसीएस जो है उसको जस्टिफाई करती है. आप मीडिया में देखते होंगे, आप उसके वेबसाइट पर देखते होंगे. एनसीएस कम फॉरवर्ड एंड व्हेन मीडिया कम टू अस, इट इज मीडिया होक्स क्रिएट बाय समबडी, मीडिया कम टू अस and we try to give a authentic information through media, through public all outreach, that this is not the fact or this is the fact, anything happens. So NCS is always forefront to give the correct information, scientific information to the public. Aftershock is predictable. जब आपका अर्थक्वेक होगा, मान लो 9 मैग्नीट्यूड का अर्थक्वेक हुआ, तो 1.2 to 1.5 मैग्नीट्यूड लेसर is expected within 24 hours. The largest magnitude lesser to 1.5, 1.2 to 1.5 from the main shock magnitude within 24 hours is expected. नहीं, 24 आवर्स में पहला आएगा, इसके बाद तो शुरू हो जाएगा ना. उसके बाद पता लग जाएगा कि ये मेन शॉक हुआ, यहाँ पर आफ्टर शॉक हुआ, देन रप्चर प्रोपगेशन का डायरेक्शन मिल जाएगा ना. देन छोटा छोटा अर्थक्वेक आना शुरू होगा, क्योंकि फर्स्ट आफ्टर शॉक, सेकंड आफ्टर शॉक, थर्ड मेजर आफ्टर शॉक जो कितना कॉम्पैक्ट रॉक ब्रोकन हुआ है उस पर डिपेंड करता है. तो यदि जैसे कि सुमात्रा का अर्थक्वेक, सुमात्रा अर्थक्वेक जब 9.3 मैग्नीट्यूड हुआ तो 1, 2, 3 कंटिन्यूअसली 9.9, 8.8, 8.3, 7.3, 7.4 सब जो है अंडमान निकोबार के लिए आया एकदम कंटिन्यूअसली. तो दीज आर द मोर डेंजरस एक्चुअली आफ्टर शॉक्स. सो दो मेन शॉक के बाद precaution is most essential to take. Come out from house, not to stand on that, it is already advisable.
Which wave is more dangerous?
आफ्टर शॉक में all आफ्टर शॉक भी तो पी वेव से ही जनरेट होगा. आफ्टर शॉक का मतलब होता है कि मेन शॉक का जो पेरिफेरी है उसी के बीच में टूटना शुरू हुआ. जैसे आफ्टर शॉक बोलता हूं, जैसे एक घर में मालिक एक जैसे आपके ऑफिस में सोनी साहब गुस्सा हो गए आप पर, आप किस पे गुस्सा हो गए? अपने सबॉर्डिनेट पर. वो कुछ पे होगा उससे सबॉर्डिनेट पर, ये आफ्टर शॉक शुरू हो गया, क्योंकि आपकी जो इन्फ्लुएंस जोन जो है अब वो इंपैक्ट होने लगेगा. तो अर्थक्वेक जब मेन शॉक एनर्जी जब जनरेट होता है, इट वाज स्प्रेडेड टू ऑल, मींस मोस्ट ऑफ द रॉक मासेज इज एट द वल्नरेबल पॉइंट टू ब्रेक. अब कब ब्रेक करेगा? ये स्टार्ट टाइम टू बिल्ड अप, कितना स्ट्रेंथ रह गया उसमें. यू अंडरस्टैंड दिस?
Killing sir.
Sir, so nowadays tunneling of over mountain areas.
हाँ.
सर IMD जो इम्पैक्ट बेस्ड फोरकास्ट देते हैं, जैसे कि हेवी रेनफॉल हो रहा है, पर्कोलेशन हो रहा है हिमालय में, सो व्हाट अमाउंट ऑफ इम्पैक्ट बेस्ड लैंडस्लाइड हो सकता है, पर्टिकुलर क्वांटिटी आइडिया दिया जा सकता है इसके इंफॉर्मेशन में?
That is good point. Actually, earthquake is also going to be, I think, and India may discuss with us that you give the impact-based earthquake warning. That means what earthquake हुआ, impact कहाँ होगा. So we are giving on SEC map now. So we are now going to convert.
I'm asking about the impact of rainfall, जिसके बेसिस में the landslide हो रहा है.
But that can be done, but it should be rain. You see, rainfall everywhere is not the homogeneously to trigger the earthquake. जैसे मान लीजिए वाटर कहीं पर जाके जाना है, वाटर कहीं जाके रुक गया, seismic zone तक नहीं पहुंचा. So it is case by case. Rain can induce the earthquake, but rain cannot induce the earthquake everywhere. It depends on tectonic conditions when it hastened the slip. So suppose in this monsoon season, water is going and arrested at the depth of the 1.5 kilometer. But seismogenic zone is the 3 kilometer. Okay. So it is not reached there. But in the it might be have some intermittent rain come next monsoon season. It was the stopper will become weakened, and then water can percolate to the gushing to there. It can be done. Landslide can be done. Landslide is secondary event. You see, so there is a lot of the landslide on precipitation, like threshold value of the this is there. They can tell that threshold पानी जा रहा है, इस पर आ जाएगा threshold. There is also the cloud based rain forecasting also. Drizzle हो रहा है continuously. There was a lot of the continuous rainfall. Then what will be the landslide? It was the drizzle. Then what is the landslide? Means all 4 categories of the cloud, they have been made like that. But it needs a lot of holistic coordinations. Okay, can be done, but coordinations needed. We are working in silo.
Yeah, Emo Chennai, you may please ask your question.
Sir, please.
Emo Chennai,
Sir,
yeah, please.
Sir, nowadays more tunneling in the mountain area is going on for giving highways and all. Whether it will affect the seismic zone category 3 or 4 or something like that, sir?
You see, I told you that Earth, none of the part of the Earth is devoid of the seismogenic activity. Today is seismogenic activity, tomorrow may be lesser, or day after tomorrow may be more. So if Earth is seismogenic, entire the process of the development, either the dam or land, the tunneling or the big building or nuclear plants, it is happening. But there is an engineering solution for that. I told you that we have to make, just like in the Debang multipurpose dam in the NHPC, there is the Arunachal Pradesh 300-meter highest concrete dam. It was the seismically designed by our tomography when I was in Geological Survey of India. So we given the design that the maximum magnitude of the earthquake 8.79, the dam will be the resistant and its building structure will be like that. So tunneling and everything can be made in the seismogenic zone with a proper design, because there is a lot of the good technology there. To our target is that earthquake shaking should be, impact should be minimized. Means its shaking will be scattered, shaking amount will be the dissipated, it should be absorbed, right? It should be attenuated. That is the target actually, and we can able to do that. So development cannot be stopped because of the seismogenic zone. Precautions and engineering solution can be adopted for making the these type of the structures. Okay. And Japan, you can see, even the Japan is the most seismogenically active zone, where also there is the tunnel, more number of tunnels. There is the airport in the Kansai Sea. There is a lot of the landslide prone zone, but they have been taken almost all precautionary measures. So I think you have to minimize the losses as less as possible or as minimal as possible by the engineering solution, which is already proven track of the technology available.
Sir, one more question, sir. Sir, after the earthquake of great intensity, great magnitude in the 2004, the climate change actually got triggered after the earthquake. It is belief, general opinion. Is it true, sir? How far is the
it is true.
climate change?
It is true, because I told you that 9 magnitude earthquake has capability to tilt the axis of rotation. In that time, the India axis of Earth rotation was tilted abnormally. The value was not remember, but it was the 0.012 or 0.05 maybe. And this axis of rotation changes, so there is abnormal changes in circular motion. So that could be the impact actually. But it was healed down, come to the normal position very quickly. Okay. So it is quite natural that climate change will be impacted by the bigger mega earthquakes. That has that has capability because of the high amount of energy released and having power to tilt the axis of rotation from normal to abnormal, and that leads to the changes in the earth system science processes.
So now it's time to thank today's speaker, Dr. Mishra. So we express our thankfulness and gratitude to Dr. Mishra. So please join me in expressing our thanks to today's speaker.
Thank you.
And now it's time to express our gratitude for sparing that valuable time with us. Actually, now I feel honored to felicitate Dr. O.P. Mishra. मुझे ऐसा लग रहा है कि मैं खुद सम्मानित हो रहा हूँ उनको सम्मान देने में. So it's a great honor for me.
The honor to me. Thank you. Very good. So nice of you.
A
तो अपना था.
few more moments here. So, on behalf of India Meteorological Department, we thank today's speaker, Dr. O.P. Mishra, for kindly sparing time with us. And I also thank our all colleagues who are organizing this series of lectures. All thanks to all the audience. Tomorrow also we have a very interesting lecture by Dr. Uma Kumar. Dr. Uma Kumar is a professor in AIMS, New Delhi, and she is the doctor who established first rheumatology department in India and at AIMS. And she works on how actually weather and air pollution is impacting the human immunity system. And then another lecture is by Director NRSC, Dr. Prakash Chauhan. So both the lectures we are organizing tomorrow starting at 3 p.m. So I request all of you to again join us tomorrow for these two very important and very interesting lectures. Thank you all. Thank you very much.
Thank you.